Welcome to the presentation of our take-home paper, Building Knowledge Through Action, Considerations for Machine Learning in the Workplace by Lindley and me, Denise Wilkins. In this paper, we report findings from two qualitative studies about the types of action people take as part of work and analyse how these relate to the generation, sharing and use of organisational knowledge. We draw on our findings to discuss how machine learning systems can support these actions and complement these with considerations for design. We argue that, because interactions between people and machine learning systems are often implicit, they range challenges for how people have control over what's shared and with whom, how they are recognised for their work, and how skill is developed. The take-home message from the paper is that working people build knowledge through the actions they take in their everyday work. While machine learning systems can support and perform some of these actions, systems must be designed carefully if we are to preserve, recognise and develop the knowledge and expertise of working people. In this short video, we'll provide more detail about the background to the work and approach used, and then we'll give some examples of the findings and analysis. We'll begin by sharing some definitions. Organisational knowledge is defined as the codes and routines that guide organisational action. Existing research shows that there are different types of knowledge. Explicit knowledge has already been articulated and formalised. It's likely to be expressed in words, numbers, or formulas. Examples include diagrams and sentences. Implicit knowledge has not been articulated or formalised yet. It's likely to be inferred from actions and behaviour. Examples include task-based skills and know-how. There's also tacit knowledge, which is very difficult or perhaps even impossible to articulate or formalise. It's likely to underpin values, practices and emotion. Examples include intuition and movement-based skills. In this paper, we're particularly interested in implicit and explicit knowledge. But why does this even matter? Let's zoom in for a moment on one of the opportunities presented by machine learning. Traditionally, people needed to explicitly contribute information to organisational knowledge repositories and seek out content added by others, both of which take time and effort. Machine learning can streamline this. Machine learning systems can mine content and add it to knowledge repositories without any explicit effort by the user. They can also recommend content in the flow of work, reducing the need to search for it. They may even highlight unknown unknowns, a long-standing challenge in organisational knowledge. These interactions may often be implicit. They are not initiated by a person, and the person may not even be aware of them. Machine learning systems may also be able to make inferences about implicit knowledge, such as task-based skills and know-how, which have not been explicitly articulated by organisation members. This is another long-standing challenge in the design of organisational knowledge systems, and again, it likely involves implicit interactions. It's important to note then that there's a trade-off between implicit and explicit interactions. While implicit interactions reduce time and effort, they also reduce intentionality and awareness, so people may struggle to understand their contributions to a knowledge repository, or even to feel in control of them. The challenges this poses for designing systems that are transparent, explainable and interpretable point us to considerations for responsible AI. These considerations have not been deeply explored in HCI or CSCW research in relation to organisational knowledge bases built by machine learning. Understanding these challenges is especially important now due to recent innovations in foundation models. Foundation models can build upon organisational knowledge and also mediate the ways in which it is disseminated. As these are deployed in the enterprise, it becomes even more important to understand the implications of shifting the ways in which knowledge is generated, shared, and applied at work. In this research, we wanted to explore how might we design machine learned knowledge bases that help users interact with and act on organisational knowledge. We asked two complementary research questions. First, how can the actions that constitute work inform the development of machine learned knowledge bases? Second, how can machine learned knowledge bases facilitate the accomplishment of useful practices in the workplace? In doing so, we draw on the literature in HCI and CSCW that has foregrounded challenges to designing organisational knowledge systems. In particular, we were mindful of critiques of the idea that knowledge can be captured and stored in a transferable or reusable form. We focus on the idea of useful practices rather than the more familiar concept of best practice. And this conceptualisation draws on Orlikowski's argument that usefulness is contextual and that knowledge work is work that can be adapted to the situation at hand.
To explore these research questions, we conducted 2 studies, a diary study plus follow-up interviews with 19 participants, and 2 workshops with a total of 12 information workers. We wanted to focus on how knowledge is socially enacted as well as on how it is generated, so we explored both collaborative actions and knowledge actions. The first study focused on collaborative actions, defined as the actions people take in relation to other people as part of work. In the second study, we researched knowledge actions. Here we focused on actions taken in relation to key pieces of knowledge that are used or produced as part of work. In both cases, we were interested in actions rather than goals, so while a person might have the goal of producing a presentation, the lower-level actions that are part of that might include searching for content and images, meeting collaborators to gain consensus, getting someone more senior to sanity check it, and following up after the presentation to agree on next steps or to answer questions. Actions were identified from diary entries and workshop activities, and in both cases were inductively coded and clustered into categories. You can dive into the categories of collaborative actions and knowledge actions in the paper, and you can also read in depth the framework that was synthesised from the 2 studies. The framework has 5 categories of action, which relate to the production of knowledge, the coordination of work, the verification of knowledge, its delivery, and actions taken to embody or internalise it. In this video, we'll focus on only 2, which relate to the production of knowledge and the coordination of work. These relate to 2 types of work that have been discussed in the literature. The first is at the heart of knowledge work, the type of work that perhaps most of the people watching this video do. Actions that are bound up with the production of knowledge include generating data, for example by experimenting or observing, gathering information from repositories or from other people, and synthesizing content, for example by reviewing different sources and pulling them together. The second type of work is articulation work, which has been described as the work to make work work by Schmidt. This is something that all workers do. Knowledge workers, managers, admin, staff, frontline workers. It includes things like organising logistics to get work going, aligning direction so that everyone is working towards a shared goal, and coordinating activity by, for example, tracking actions or meeting regularly to update colleagues. Drawing these out in relation to explicit and implicit contributions helps to highlight the different ways in which work can get contributed to a machine-learned knowledge base, and also helps highlight opportunities and considerations for design. For instance, when workers are focused on producing knowledge for their organisation in the form of a deliverable like a document or presentation, they can choose to explicitly add that to a knowledge repository. And if that content is a video that demonstrates tacit knowledge, that too could be added explicitly. Alternatively, a machine learning system may mine content and add it to a knowledge base without a person needing to do anything, or even being aware that this has happened. In other words, that interaction would be implicit. And finally, systems could potentially draw inferences from the actions users take to, for instance, evaluate the quality or usefulness of the content in the knowledge base. And here, both the knowledge and the contribution would be drawn implicitly. A knowledge base that learns from efforts to produce knowledge could obviously incorporate that knowledge and then help organisation members find it, reuse it, or contact the people who helped generate it. But these also highlight a number of considerations for design. These include making people aware that the knowledge they are working to produce has been contributed to a knowledge base, especially if there is a risk of oversharing or misinterpretation by others. These questions become more complex when content is configured from a combination of multiple pieces of source material. In those circumstances, it becomes more complex to remove content from the knowledge base or to communicate authorship, and perhaps also determine accountability. An additional risk relates to how such systems may potentially introduce or reflect filter bubbles and biases, and consequently affect people's opportunities to have impact within their organisations. This may become especially relevant if, for instance, a system becomes bound up with the analytics that are associated with performance.
If we ask the same questions in relation to articulation work, we can consider how this can result in implicit or explicit contributions to machine-learned systems. For instance, organisation members could explicitly upload project plans or other resources to support coordination to a knowledge base, or this could be mined implicitly by machine learning. Machine learning systems could potentially also identify details such as deadlines or actions from tools such as Trello or Slack that are used to coordinate work. Finally, there's the possibility that these details could be inferred from the actions of team members to build models about project roles, timelines, and so on. Again, this raises both opportunities and considerations for design. Systems could generate suggestions to support project setup, or perhaps help and alert team members regarding the use of shared resources or status to agreed action. Centralising planning and keeping records up to date were both highlighted as challenging for our participants. So, such systems might also recommend possible actions based on inferences of work in process, or alert people when timelines and actions need to be adapted to changing circumstances. Considerations here include how to make users aware of the mining of procedural knowledge. While people are used to the concept of adding permissions to content to control who can see it, it's not clear how this translates to sharing how that work was conducted. If work in process can be determined from the ways in which project teams operate, who should the details of that process be shared with? Should that audience be organisation-wide? Do people feel possessive over knowledge about the ways in which they work? These are all questions for further research. A second consideration relates to risks to agility and innovation that can be introduced by workflow systems if workers fall back on system recommendations, especially if the underlying data becomes outdated or corrupt. A final consideration relates to how design can acknowledge the ambiguity and flexibility that's inherent in working processes. Machine learning applications that are used for making recommendations regarding how work is conducted may present an additional risk if that procedural dimension of work becomes automatic and mindless, rather than, for example, being reflective and mindful. How can system designers identify which actions are mundane and which are a valued part of work? You can read more about these considerations and others in the paper, but we'll wrap up now by returning to our take-home message. We called the paper Building Knowledge Through Action because our analysis illustrates the potential for machine-learned systems to build repositories of both implicit and explicit knowledge, often by drawing on people's content and actions in ways that are implicit, or in other words, that happen without their awareness. While this has the potential to address some long-standing challenges in developing organisational knowledge systems, it may also have ramifications for working people and for organisations. In particular, if machine learning systems support or perform actions for people, this may impact the ways in which those people are able to develop their knowledge and skill. In addition to the many considerations highlighted in our talk and in the paper, which relate to agency, authorship, and flexibility, we conclude by underscoring the importance of designing systems to preserve, recognise, and develop the knowledge and expertise of working people. Thank you for listening to our talk. If you're interested to learn more, please read our paper. And finally, a big thank you to all our colleagues who contributed to this work through feedback, conversations, and knowledge sharing.